A Bugatti Chiron has 8 gears. A Formula 1 car has 8. A Ferrari SF90 has 8. A Tesla Model S Plaid has 1. Same acceleration figures. Same top speed range. But one has a transmission that costs more than most cars. The other has essentially a fixed gear ratio. How is that possible? The answer isn't clever engineering. It's physics. And once you see it, you'll understand why the entire concept of a gearbox is disappearing from the road. Let me show you. To understand why a gasoline car needs a gearbox, you need to understand what a gasoline engine actually does. An internal combustion engine only produces useful power inside a narrow window of engine speed. For a typical car engine, that window is between about 1500 and 6500 RPM. Below 1500, the engine barely produces any torque. It stalls. Above 6500, valves start floating, combustion becomes inefficient, and you risk destroying the engine. So the engine is only genuinely useful across a range of maybe 5000 RPM. But your car needs to go from 0 to 200 kilometers per hour, and the wheels need to spin at wildly different speeds depending on how fast you're going. At 60 in first gear, the wheels are turning slowly. At 208th gear, they're turning very fast. If the engine can only work between 1500 and 6500 RPM, but the wheels need to spin at everything from 0 to nearly 2000 RPM, you have a problem. You need something between the engine and the wheels that can change the ratio. Something that lets the engine stay in its happy zone while the wheels do whatever they need to do. That something is called a gearbox. First gear is a huge reduction. You spin the engine fast, but the wheels barely move. They give you enormous torque at the wheels for starting from stop. Eighth gear is almost a direct ratio. The wheels spin nearly as fast as the engine, which is efficient at highway speeds. A modern Bugatti or Porsche has an 8-speed dual-clutch gearbox with roughly 600 moving parts. It costs $80,000 just for the transmission, and it exists for one reason: to hide the fact that a combustion engine only really works in one narrow band. Now let's look at an electric motor. An electric motor produces its maximum torque from the very first rotation, not at 1500 RPM, at 0 RPM. Standing still, if you apply full current, you get full torque. And the torque stays flat, roughly constant, from 0 all the way up to about 5000 RPM. Then it starts to fall off gradually. Power stays high until much higher speeds. Think about what that means. There's no bottom. There's no top. The motor works everywhere. You don't need first gear for a huge reduction because the motor already has maximum torque at 0 speed. You don't need 8th gear for efficiency because the motor is efficient across a huge range of speeds. So how many gears does an EV need? 1. Well, sort of. It's not really a gear in the traditional sense. It's a single fixed reduction. In a Tesla Plaid, the motor spins about 9 times faster than the wheels. That ratio never changes. There's no shifting, no clutch, no torque converter, no synchronizers. Just a couple of gears that spin at a permanent 9-to-1 ratio. That's it. That's your entire transmission. The result is a system with maybe 20 moving parts instead of 600. Almost nothing to wear out. Almost nothing to service. No transmission fluid to change. No clutch to burn. Now you might be wondering, if EVs only need 1 gear, why does the Porsche Taycan have 2? This is actually a fascinating engineering compromise. The Taycan is designed to be a proper sports car. Porsche wanted extreme acceleration and extreme high-speed efficiency on the German Autobahn. Those two goals pull in opposite directions. For maximum acceleration, you want a very short gear ratio. Lots of torque multiplication. But that means the motor spins fast at highway speeds, which wastes energy. For efficient high-speed cruising, you want a long gear ratio. But that hurts acceleration off the line. Most EV manufacturers just picked a middle ground. Porsche didn't want to compromise, so they added a second gear on the rear axle. First gear is a short 2.85 to 1. Second gear is a longer 8.05 to 1. Around town, The Taycan uses first for maximum response. Above about 80 kilometers per hour, it shifts in a second for efficiency. You don't feel the shift because the motor's torque curve is smooth enough to make the transition seamless. But here's the thing. Every other manufacturer looked at Porsche's solution and said, no thanks. The added complexity, weight, and cost just wasn't worth the small efficiency gain. Even Porsche has been considering going single speed for the next generation. So gearboxes are dying. But we can go one step further. Right now, even a single-speed EV still has some drivetrain. A motor at the front or rear, connected to a differential, connected to half shafts, connected to the wheels. Those parts still have friction, still have weight, still cost money. The next step is putting the motors directly inside the wheels. In-wheel motors. Each will get its own motor with no gears between the motor and the road at all. Companies like Aptera and Lordstown built prototypes. Rivian and Rimac have shown patents. The problem is unsprung mass. Putting heavy motors inside the wheels ruins the suspension geometry and hurts handling. Engineers are still solving that. But when they do, the concept of a car drivetrain will finally be complete. 4 wheels. For motors. Software controlling everything. No gears anywhere. The mechanical car, as we know it, will be over. And the funniest part? The physics that killed the gearbox was known back in 1888 when Nikola Tesla patented the induction motor. Engineers just spent 130 years designing around it because combustion engines forced them to. Next week, I'm digging into something that's been quietly reshaping the entire EV industry. Not the batteries, not the motors, the software. Specifically, why Chinese EVs are running rings around Tesla and features that most Western buyers don't even know exist. New videos every Wednesday. Subscribe if you want the full engineering breakdown when it drops.